Hello, and welcome to the Professor Podcast with Ruth and Claire. Each episode, we talk about a particular topic in the life of a professor. Ruth is a visiting professor at a large university in Ireland, and Claire is an associate professor at a primarily undergraduate university in Northern California. The purpose of our podcast is reflection, so we bring something we think is working and something we're working on to discuss. Welcome to the Professor Podcast with Ruth and Claire. I'm Claire.
And I'm Ruth, and today we're talking about scaffolding student learning. But before we do that, Claire, how was your week?
My week was great. I've had a fun chat with a in-law relative, one of Ralph's aunts, and she was saying, so she teaches teachers how to do good learning practices. She's
cool.
In like elementary school, middle school, I believe. And anyway, so we were chatting about that, and that was really interesting. And then I was saying, somehow we got on the subject of the worksheets that I do in class and how I really like them. And I have some lectures where it's more me talking and them talking and we're going back and forth. And then some lectures where they're doing group work and they're doing these worksheets. And the way I see it is they're, scaffolding some learning and really building up these skills and developing new material and all that during their worksheets, but sometimes I can't really convey that. Even though I try to say all that directly to the students, there's always a couple students who are like, oh, are we just doing a worksheet day? Then I'm out of here, And Ralph's aunt said, you need to call them something besides worksheets. And I said, really? And she said, when you say worksheets, I'm thinking rote learning. I'm thinking it's going to be terrible. And she thinks the students think that too. And I was like, I never even thought about that. But that's a really good idea.
And maybe it has a different meaning like in high school or their experience.
Sure.
They're interesting.
And so,
okay,
I'm accidentally sending some signal. Sorry. You go. Oh, yeah, so I'm accidentally sending some signal potentially by calling it a worksheet. And if I simply called it something else, I wouldn't be triggering all those, worksheets, whatever that means. So I'm really interested in I'm coming up with some new name for it and seeing if that has an impact. Because to me, worksheet just meant, we have a paper with some holes and you're filling in the holes. But but there's millions of ways you could do that. So anyway, I'm really interested in giving that a shot and seeing if some of the negative response that I get from a small percentage of the students gets ameliorated.
I was just going to say, we should put it out to the listeners who are like, please tell us what the names, because I'm trying to think what I call, like when we do, I feel like here it would be called tutorials, but we have activity, and I call it like the activity. Mm-hmm. That's what I call it. I don't know.
Great.
But like, I think that still might be a little, I'm saying childish because I can't think of another word, but they might kind of see it as something. That's so interesting.
Yeah, because I'm seeing it as we're actually learning something new. You've gotten to this point, and we're going to get to a further point with this worksheet. And so it's not. Yeah. So maybe I need to come up with a name that includes new concept, or I don't know, something like that.
It's so interesting that you're saying this because when my kids come home, like with worksheets in their bag, they're always crumpled up at the bottom of the bag, possibly with a banana smeared on it, like which is always ever present in the bag. But do you know what I mean? It's always, to me, I'm like, oh, why aren't they doing their book work? Mm-hmm. Like to me, worksheets always seems like something like, oh, we're just filling time or something, which I am sure is not true. And I don't even know where I got that from, but that's so interesting.
Right.
That is what I think. Except when it's my worksheet. And then I'm like, this is
my worksheet is obviously different. Yeah, totally. Well, that's a great idea. Yeah, listeners, if you have some other name that you call your worksheets or a suggestion for how else to call them, I would love to hear.
Yeah, let us know. Yeah. It's super interesting. Yeah.
So
cool. Well, I'm excited to see. Oh, my week. Yeah, so it was really good. I feel like I was like, what did I tell you this weekend? Like, because I feel like especially now we don't see each other very often. So I'm like, I almost want to tell you like 50,000 things. But anyway, some of the highlights are last week, a very good friend from our university, Tracy, texted me and was like, have you seen this show Bad Sisters? Which I hadn't seen. And she was like, because it's set in Dublin and a big part of it, they're always going swimming all the time.
Oh, no way.
Yeah, and so she was like, is that where you go swimming? So I was like, oh my goodness, I want to watch this. So I watched it, and they go swimming in the 40 foot, which is on the other side of the city, where I think I have gone before, but that's not where I go. But it's a really good show. It's very funny. It's a kind of dark comedy, but it's very good. And a lot of it is they're going swimming in the sea. And then there is a bit where my swimming spot shows up.
No way.
In episode 3. So I was very excited about that. But I was also thinking about, I have been bringing the girls to the pool.
Uh-huh.
Because both of them were like almost about to learn to swim right when the pandemic hit. And then they haven't. So I was trying to look up lessons. And they were referring to like overage learners. For like anyone who's over 8, which I guess is now my daughter is that. And I was like, oh my God, that's really shaming. But I was just thinking, like, the pool is the exact opposite of going to the swimming spot. Like, it's just so, like, clammy and like, you know, like, I don't know. I find swimming pool dressing rooms so stressful. Everything is slippy. The kids are like flopping around. It's just like, and then like just being at the sea and you're looking at this beautiful ocean outdoor. Like, it's just so much nicer. So anyway, that's my, recommendation. No. Bad Sisters.
Bad Sisters, episode 3, we get to see your swimming spot. That sounds really cool, because I have this very clear image in my head of where you're swimming, but I completely made it up. So it'd be nice to see what it actually looks like.
That's awesome. Well, it's weird. It's like these old shelters that I've walked by for years.
Uh-huh.
And somehow, I don't know what it is, but you can't see anything from the outside.
Mm.
And like, so sometimes you'll go in and think there's nobody there and there's like 50 women there. You're like, what is happening? It's some kind of weird optical illusion. So anyway, it's very cool.
We will look it up. And I'm sure your daughters will learn how to swim soon, and it will be so cool, because then they can move upgraded from the pool to the ocean.
I know. It's just so nice. I went today and it's quite humid here, and it's just a reset. It's very lovely. So yeah.
Cool.
So I have like a made-up quote.
A made-up quote? What does that mean?
So I'm going to tell you what the thing I'm saying is, and then I'll tell you what way it's made up. Is that okay?
Yeah.
So into the ocean I go to lose my mind and find my soul.
Ooh.
And so, so I was Googling swimming quotes, because that's where my head's at the moment. And this is actually, the real quote is, into the forest I go to lose my mind and find my soul. But I think the swimming community has adopted it. So it's by John Muir, Muir.
Mm-hmm.
So anyway, so it's a slightly made up quote. But I think both of those work. Whatever your thing is.
Yes, that makes
sense
to
me. You go into it and then lose your mind and find your soul.
It was the forest, but for you, it's the ocean.
Exactly.
Yes. I love that.
Yes.
Was it to find yourself? I do. It does seem like it centers you to go into a nice, natural place that really is nice for you.
Well, yeah, and there's something... So I don't know if any of the science about this is true, but I'm going to just go with it. But I have like a really intense startle response. Like, it's really bad. Like, and it's mortifying, because sometimes someone will just like walk out of their office and I will like scream and drop stuff, and then they're like, sorry, and I'm like, no need, like, you really just were doing a normal thing. And anyway, so there's something about the cold water, and you kind of get a bit of a shock when you go in at first, and then you kind of calm your breathing down. And so I think there's something, I feel like my startle response is better.
Interesting. You're practicing calming yourself down after freezing.
Which feels like it's the opposite. Like, you're tormenting yourself, like it's some kind of self-harm or something. But anyway, I think it isn't. I think it's actually,
That's cool.
Yeah,
I
love it. But yeah, so do you want to, should we say what we mean by this? Or?
Yes. Tell me what scaffolding means to you.
So scaffolding to me means I am imagining, like, do you know, like a plant or something growing, and it has the supports. Well, this isn't working. Now, my analogy isn't working, because you don't actually take away...
You have a support up here and a support a little higher, support a little higher. Is that what you're talking about? That's
kind of. But then eventually you're supposed to take away the scaffolding, which is where my plant thing is falling apart. So, but, okay.
Well, you do, because you don't have the class anymore, or you're further along, or I don't know.
Or the plant died. No, I'm kidding. Sorry. I'm going really sideways with this. But so just basically having a lot of supports in the beginning, and then slowly removing some of those... for students, right? So like, and then maybe we could talk about what that means in your discipline as opposed to my discipline, or...
Sure. Yeah. Well, so the way I'm thinking about it is, maybe I'll just say kind of what's working for me with scaffolding, and I'll be describing it in there. So, so what I think of when I think of scaffolding student learning in my class, I'm thinking about setting up like in my homework assignments, I have easier problems that get a little harder, and then harder problems. And the goal is to be able to do the really hard problems, level 4 in my homeworks, easily. But I have this set up where they can work their way up there, some kind of support to get there.
Yes.
So that's an example. And then also going about having different moments where we're exploring the same content, but there's going to be a moment where I'm doing some examples on the board of a certain kind of problem, and then there's going to be a moment where they're doing them themselves, and then there's going to be a moment where they're in groups working on one of these not worksheets that's a little bit harder, and they're learning something new, building on what they already learned, doing it together in groups or something like that. And so I don't always necessarily do those 3 things in the same order. For some topics, it maybe is better for them to start in groups and establish some baseline, and then we move to a harder problem, and I'll do that on the board, or who knows what. So depending on the topic, I've come up with kind of different orders for these different levels of support, but I still feel like we start out and we're doing it kind of simply, and I give some kind of support for that, and then we're going to take another level up, and we'll do it in some other way, building on the support that we already had from the beginning.
Yes.
So does that make sense, explaining the scaffolding?
Totally. And I love the idea of different levels. And I feel like that ties in with what we were talking about last week. I'm still ruminating a lot about the bundles. So yeah, that's super interesting.
Yeah.
And I think, do you?
No, go ahead.
Oh, okay. For me, I think that I very much... So, okay, I think there's a certain skill set that you need to develop in the physics course. And so I'm sure that's definitely true in chemistry. And especially in the first year, like I often was teaching the introductory physics. And so a big thing for me is teaching them how to set up problems and like solve problems and like show your work and do a diagram. And like things that I would see as a very much like a physicist's skills.
Yeah.
But I really do it through... Like I demonstrate a lot. So I do a lot of worked examples and I show them a lot of examples. I'm also pretty uptight about these are the kind of things that you're going to need to show me in an exam. You know what I mean? So I have it very like well defined, you know, at the beginning in particular. And then I guess as I go through, I get a lot more like, okay, no, you have a go first or you try. You know what I mean? And so...
Okay, so you're scaffolding not only the content and the skills, but you're scaffolding your expectations. Like at first you tell them more exactly. Clearly, these are the 5 things you must include in a complete problem, and then later they kind of already know that, so we don't have to talk about that. Is that kind of what you're saying? Yes, cool.
Totally. And I guess I'll talk about this more in the working on, but like... Yeah, so I do a lot of like showing people how to do problems and showing them how I do problems. And then I do a lot of extreme cheerleading as they're doing the problems. Like, yes, you're doing, oh, yes, yeah. And we're doing step 1. So we're drawing our diagram and all of those kind of things. And so, yeah, that's what's
I'm a huge fan of showing the students how to do it. I'm also a huge fan of them working to figure out how to do a new aspect of it or practicing it themselves. I think all of those are essential. But yes, showing seeing somebody who's an expert at solving these problems solve the problem is demonstrating a good way of going about it, so they don't have to develop from the start some other way that might be equally good but might not be. And certainly will be a little bit confusing if they have their way and you're doing it a different, like, you know, if you can say, look, this is an excellent way of solving the problem, I have demonstrated it for you, I think that that'll be really helpful in the students being equipped to leap into solving the problems and become experts themselves.
Totally. And I think like, so I'm going to talk about this a bit now, but like one thing that like I really struggle with is a lot of students come in with ideas about how to do physics problems that work for a certain type of physics problem. Do you know what I mean? So say like if you're talking about speed as distance over time, you can kind of like in your head be like, oh, I traveled 1 meter in 1 second, so I traveled 5 meters in 5 seconds. Like you can reason it out, and that's fine. But once you put acceleration in there and it's not at the same speed, it's a completely different ballgame. Do you know what I mean? And so a lot of students have gotten through earlier science experiences with whatever ways they're doing stuff. So I'm
it's
really
exactly the same in analytical chemistry. The students have it's an excellent, great way to solve the problem if you know there's 5 grams per 100 mils and you're making 200 mils, so 10 grams. Easy. Great. I'm totally down with you not writing that out in like super formal structure. But if then it becomes, so how many milliliters of this solution do we need to make 10 milliliters of that solution that's 5 grams per 100? Then it gets a little more complicated. Really easy if you write it out, but if you've never learned how to write it out because you didn't need to, because you can see it in your head, so that the system of writing it out is a really useful skill that will equip the students to be able to solve the more complicated problems.
Right. And I think that's exactly it. And then obviously maybe there's some people who can figure stuff out when things are accelerating, whatever. But then the next level up, they're not going to be able to do without this skill set of like presenting their work and figuring it out. So I think, yeah. Okay. You say what you're working on and then I'll come.
Yeah. Well, let me just say one more thing about that. So you're saying, I love that. Again, it's wonderful to not have to use the scaffolding, if it all makes sense for this particular problem. But it sounds like you're saying, and I completely agree with you, that one of the scaffolding things is learning the tools with the simple problems that will allow you to solve the more complicated problems later. And so, and that's interesting because it seems to me like this is, I say this all the time, but it's all about, from my perspective, communicating to the students why we're doing what we're doing. Because it's totally incredibly frustrating to be told that you have to write out all of these steps to figure out like that you just need to multiply by 2 when it's obvious. Unless it's clear that what we're doing, we're not actually trying to solve this problem. This problem is really easy. Everyone knows you need to multiply by 2. But what we're trying to do is learn a system where we can now solve more complicated problems. So maybe if we're explicit that we are scaffolding, that this technique, so maybe on the same worksheet or something like that, we could start with a simple problem where everyone knows you multiply by 2, but let's go through all the steps, and now we'll have a more complicated problem where you definitely don't know that you could just multiply by 2, but we'll go through the exact same steps and be able to solve it. That could be, just to get the buy-in. I don't know. I'm going off on being explicit about why we're doing what we're doing, but I really feel strongly about that.
I think it's super important, and I think so. Like for me as an undergraduate, I feel like I just really memorized how to do everything, and that was what I did. Which is, it's a technique. But when I got to grad school, like I had a certain professor who really just taught me how to solve problems.
Oh.
So, and I don't know how good I am at this anymore, but like I really got much better at like getting a problem I had no idea how to do and being like, okay, well, I'm going to follow the steps that we always follow. And then next thing you're kind of halfway through the problem and you're like, oh, here I am. Whereas before I would be like, oh my God, I just have to look up a problem that I know how to do. So that to me was extremely, totally. No, go ahead, yeah.
You're equipped to solve problems you've not run into before instead of being equipped to solve these 5 types of problems.
Exactly. And I feel like that's like the empowerment of physics and problem solving skills is that. So yes. Okay. You tell me what you're working on.
Okay.
Go ahead.
How did he teach you how to solve problems? That's like such a general thing. And there's so many different kinds of problems. How do you have steps to solve unknown problems?
He just always made it, and like, he just always had like very clearly defined like what was the consistent approach we were taking.
Okay.
Do you know what I mean? So every time we're drawing a diagram and we're labeling our coordinate system and then we're finding whatever it was, he just always managed to boil it down to, and I think this is a big problem with students in every discipline, is they're just like, this is just a bunch of weird tricks. And specific, you know what I mean? And they don't often see the underlying threads of like, no, every time we are doing the same thing. And I find that very soothing to have like this consistent approach. Do you know what I mean? And so, yeah, I feel like I'm being a bit mysterious because I'm like saving all of the stuff for the...
Oh, okay. Sorry. Yeah, no. Okay. So what I'm working on is, so I feel like I have a pretty good understanding of how to scaffold things when it's a mathematical calculations-based thing. Like you need to solve this kind of problem. Here's the general approach. here's some general concepts. Let's put them together. Look at all the different ways this problem can exist. Like we're thinking about solubility and what if the compound that dissolves has these type of characteristics versus those type of characteristics. What if you have two compounds together? We can really kind of scaffold within that topic because we know how to do it simply, and then we're going to just add complications. That makes sense. And I feel like I can also, even if we're starting from ground zero with, say, a worksheet, I feel like because there's a right answer and we're all logicking our way through it, I feel like I can scaffold that kind of thing.
Yeah.
What I'm not so sure about is when it's a conceptual thing, and it's something where there's just, this is how this instrument works. There are these kinds of columns. These are why you use these different columns. I feel like I do, we have back and forths. I'll say, oh, there's this kind of column. It has, little holes in the compounds that you've stuffed in the column. And so what do you think the impact would be? Would larger molecules get through faster, or would smaller molecules get through faster? And they can think about that. So we can have a lot of discussions. We can have a lot of thinking about why things are this way. What's the benefit of this way? How did they develop? There's lots of stuff to talk about besides me just laying out the facts, but I'm not really sure about scaffolding,
That's super interesting because it is. And I've taught classes before that have been more like, I am giving you information. Mm-hmm. And I've really struggled with that. Like, it's it feels different. But kind of what you just described to me is perfect, right? Where you're trying to get them to think a certain way and engage with the information a certain way. And maybe at the beginning, you really spell that out for them. Mm-hmm. And then as you go through, maybe you take away some of those training wheels and like...
Sure. And you're right. I mean, it's a little bit inherently scaffolded where we start with one instrument, and then by the time we get to instrument 2, they already know what columns are, but now we're doing columns in this different way. And so, I guess maybe I just don't think of it as much as scaffolding, but they are, of course, as always in most classes, they're building on what they already learned earlier in the semester, and they're using the skills and the thought processes that they already learned from the last topic. They have analogies on this. So there's some inherent scaffolding. It's just, I don't know. It's just not as obvious to me that it's scaffolding.
No,
it's more
and it's
just exploring a topic, and as they become more familiar with the topic, they're more equipped to add to their experience with this topic. Yeah.
But maybe that's just, like, because it sounds like we're thinking about, like, mathematical type problems as being like easy to difficult, but maybe what you're talking about just is like building context and building information and building a toolbox of being able to analyze some, like, a new piece of equipment. Maybe that is
the
end goal. So sorry.
And it also occurs to me that it is kind of sorry, go ahead.
But I'm just like, you're already doing it. That's right. No,
I think you're right. And it is, instead of going easy to difficult type of problem, like we've added more and more complications and now we have two compound, I don't know. Yeah. But instead it's more like, well, you already knew the basics of how this instrument component worked, but now let's really talk about it in more detail and how does it work? And so I suppose that's scaffolding as well. We already know that the photomultiplier tube gives off electrical current when it gets hit by photons, but now let's really talk about exactly how it does it or something like that.
Yeah.
So I suppose we're scaffolding. I just hadn't thought about it that way.
Yeah, but it is, I think we're just so much more used to the easy to difficult.
Yes.
Yeah, without, totally. And it is a different thing to teach, like, material that other way. Mm-hmm, mm-hmm. For sure.
All right, so you have things that you're working on that you've been
trying to... so here's my big fundamental crisis, right? So is just, like, maybe I should have just opened with the crisis. But, like, I've been at physics education conferences, and it has... Some of the messaging has been like, well, you can't just have students watching you do problems. That's the worst thing you can do. Mm-hmm. Do you know what I mean? And so I think I get quite anxious about whether it is okay. And I do believe in the way I'm doing it. Right. And like I guess the thing that I would, so I often think about, like, it's really cool to have creativity in science and all of that. But then I'm like, no, but you have to do the problems my way and you have to do, you know what I mean? So I'm like, but I do believe that students can end up in hairy situations when they, you know what I mean? And I think just giving them a really good underlying structure for how to approach things is really important. And I would love to do stuff that was more like, oh, well, what do you think? How do you... And, like, I can see with my daughters, because they're so little, They do. They're really creative. Like, oh, I'd try this and I do. But I feel like we squash that out of them by the time they get to university. Like, we're not dealing with... Do you know what I mean? Like, I think... So say a lot of people do inquiry-based learning where I am, which is brilliant. But I also sometimes think it's stress-inducing for students. Do you know what I mean?
And so what does inquiry-based learning look like in this example?
So say in this example, it's more like trying to get them to construct things.
A way of solving this problem.
Exactly. Rather than me being like, you're going to watch me do 4 problems and then you're going to do one yourself. Like that. Do you know what I mean? And so I think I struggle with like really being like, yeah, we should get the students and empower them. And then I'm like, no. But also, you know what I mean? So I think...
Interesting. I mean, do you feel like... It kind of makes me feel like, is it really an all or nothing thing? Like,
Yes.
I'm sure when you give them a problem, at some point they're doing a problem that has something that you didn't already tell them how to do, or it's a different combination or something, and that seems like there's a little inquiry. Or on the other hand, if you help them, if I had a bunch of students and I was like, okay, figure out how to solve this kind of problem, yeah, I would agree with you. I feel like for sure at some point, even if they've developed wonderful methods, I need to say, this is the method that I do. And it works really well. And if you have a different method that you love, I'd love to chat with you about that. And maybe their method would be brilliant. And maybe it would be brilliant under these circumstances. And regardless, I would like for them to know this well-established method that a lot of people use so that they're familiar with it.
This is exactly my thing. And I've just had so many times where students like, oh no, I solved it this way using triangles or something, and it happened to give the right answer, and you're like, okay, I don't know why it gave the right answer, but this is not, you know what I mean? Like, you have to learn this method. So I guess for me, and I think I do scaffold it, right? Because I do it, but I really encourage students, okay, you can do it, let's see it. Like, I don't just make them watch me do problems indefinitely. Right. Do you know what I mean? But I guess I get anxious that, like, I'm being too prescriptive, but then I do believe I should be. So I don't know where my anxiety is, just that, like, I'm being a bad old traditionalist physics teacher.
Sure. Your anxiety is that the modern lingo is saying you should be inquiry-based, and you're feeling like that would be too far away from you showing them how to do it properly.
Right, and I really, so again, back to my kids, but they're so interesting where, like, when they're in certain parameters, they're super confident and feel safe and they know exactly what's going to happen and they're just having a blast. And when they are not in those parameters, like if they're in a group of kids they've never met before or something, they're like, just like to stay back and observe things. Or if they don't know what the structure is, like one of them has gotten a teacher in school now who's actually pretty strict. But she's loving it because she knows exactly what's going to happen when. Right. Do you know what I mean? And so I think, especially with the way our education system works, like I think students just want, like, and then they can blossom in that structure. But I really think they need the structure. I agree. Do you know what I mean?
Yeah. And it is, it makes me feel like I took a class in college where I took multiple classes, but the one I'm thinking of where we were always in groups and we were always working on problems, and maybe you would say that's always inquiry-based, like completely. As far as comfort in the classroom, that was there because I knew exactly what we were doing. I was in the same group. We were every time we came in and we tried to, so that was there. But for me, I really could have used somebody showing me how to solve this problem. Or even if at the end of the discussion, if somebody just said, so here's how you solve it, that would have really helped me. And so I agree with you completely and wholeheartedly that having the actual, this is a great way to solve the problem, this is how you do it, this is a good approach, somewhere, I don't care if it's before, if it's after, if it's in the middle, but it needs to be somewhere. I totally agree with you. That's core to my teaching philosophy as well.
Okay, yes, good. Maybe I just wanted a bit of reassurance. Maybe we could have done this in like 3 minutes. And I'm like, is this okay? And you're like, it's okay. But I think one thing I have thought about, which is, I'm not super, I feel like I do this, but I don't, it's not like I'm like, oh, I've shown you for the first 3 weeks, I will do every single step in the problem. And then I don't have it.
But it happens naturally, out. Sure.
Yeah, like it's a lot more intuitive. And I'm like, is that okay? And then different students,
I think, yeah.
Right, and I think different students need longer hand-holding Do you know what I mean? But I guess my fundamental thing is I believe hand holding is okay. Not obviously physically because that's inappropriate, but you know what I mean? Like, it's just like providing that support and structure, I think, and I think especially for anxious students, like I think it's very empowering. So yeah, that's okay.
Yeah.
The end.
No, totally. I agree completely. And I do that too. You know, the first time we solve the problem, I do every single step. And we do that a bunch of times. And then at some point I'm like, and then you solve the algebra and x equals this, you know? And if somebody's like, wait, I'm not getting that, then we'll go through it. But usually if someone's not getting it, they're like, oh, I'll just ask you later. And, oh, it turns out I forgot to multiply by 2 at this one. Or I don't know, whatever it is, you know? So yeah, I totally, I agree completely.
Yeah, and I guess fundamentally, now that I'm just saying, like, physics is a discipline, and like every discipline has its own structures that are really important.
Right.
And maybe I just need to be okay with that and be, there's a movie that I really love called, it's not a great movie, but I think it's a great movie. It's called The Day After Tomorrow.
Okay, I don't know it.
It's just like action drama movie, but there's a bit early on, so I think it's a perfect movie, except for one scene where the kid is complaining to his dad. His dad's like, you got an F in calculus? And he's like, it's just because I didn't show my work, but my teacher like graded me 0 because I didn't show my work. And that just means they're stupid. And I was like, sorry, sir, you're incorrect. He needed to show his work. So that's like, yes. I think I'm a lot more uptight about these things than I think I am for all of my, Sure.
And if it's, as long as you're clear, you need to show your work, which you are. And I think you can get the buy-in, like we've talked about, by saying, this is why you're doing it. There's going to be harder problems where it would be really helpful to go step by step. So I really want to make sure that you know the system. I'm making the circle motion. The system.
Yes, I know. This is the time I wish we had a YouTube, because this is, I like it.
So, okay. We'll continue to
Thank you.
Show the problems.
Yeah, and I think I just wanted the blessing for that. And I think actually just even doing this, thanks. Like, you did the circle motion. That feels like a blessing in some way. But I think that, I think I just wanted, because I do get this anxiety sometimes of like, oh God, am I being too prescriptive? But I think I'm not just, I guess there's always a danger in education that you just regurgitate what happened to you as an undergrad. And I guess now I've interrogated this a bit, I actually feel good about it.
Yes, that's great.
So
yeah. And I also, last thing I want to say about this is that for you, it might seem like this is pretty much the exact same thing that they're working on afterwards. But for them, it's quite different to work on it by themselves. The differences in the problem are significant, not trivial, between the problem you did on the board and the problem they're doing now. And I bet they're doing a lot of that inquiry stuff. They're not just copying what you wrote on the board, but with different numbers. They're having to think it all through. So I think it's probably, just because you're so familiar with the problems, it's probably seems like you're further from inquiry than you are, you know?
Yeah, okay. Thank you, Claire. We should change this podcast to just Ruth's anxieties and Claire soothing them.
That's such a useful way of picking topics, is when we say, what is bothering me right now? Or what am I thinking about? Or what, you know, so it's really good.
Well, it's like, I remember going to another thing and someone was like, well, it's not like you write your syllabus by just looking at the table of contents of the book. And I was like, oh, really? Is that not what we do?
I mean, if it's a table of contents, I'm into it.
Sure, totally. It's
Somebody
like,
thought it was a good summary.
Well, you're not just going to stand there and solve problems and have students look at you. And I was like, no, is that not what we're doing? So, yeah.
Yeah.
Yes. Okay, cool. Thank you, Claire. That was super helpful.
Thank you, Ruth.
Thanks so much for joining us on the Professor Podcast with Ruth and Claire. We're delighted to have you as a listener, and we would love to hear from you. And if you want to email us, our address is contactprofessorpodcast@gmail.com. We'd love to hear any of your suggestions for future shows, or professor quotes that you might want to share with us, or even just things that have come up for you when you were listening to previous episodes. And if you've been enjoying the podcast, we would love if you would spread the word. So the best way to spread word is by telling people you know, if you think they should listen to it, or you can leave us a review wherever you listen to your podcasts. Thanks so much for joining us, and we'll see you next time.